So this is section 8.4, guys, how to perform a two-sample z-test for the difference between two proportion, P1 and P2. So one proportion from one sample, one population, and another proportion from the second population. Let's state, guys, how would you state the null and the alternative hypothesis? And it's not going to be any different from this one, guys. The only difference, instead of mu, I'm going to put P1. So the scenarios that you would have, it could be this. That's one scenario. Or it could be, and I want one student to give me the last scenario. That's one scenario. What would be the last one, guys?
Equal and not equal.
Very correct. And if you guys can come up with a fourth choice, let me know, but it's not possible. You could not come up with a fourth choice. You have to choose one of the three. So you guys, when you do work in this section, just put those three scenarios in front of you and see which one will make sense, just to select. If he asks you to test that the two proportions are different, definitely it's going to be this. If he asks you to test that the first proportion is greater than the second one, it's going to be that. If he asks you to test that the first proportion is smaller than the second one, it's going to be this one. So just read the problem carefully and you should be able to get which one. It's very important that step number one to be correct, because step number one is not correct, everything else is going to follow and won't be correct. Okay, what are the conditions of the test, guys? The samples must be randomly selected. The samples must be independent, like male, female, different groups, two different, totally different groups. And the samples must be large enough to use a normal sampling distribution. We need to verify N1 P1 greater than 5, N1 Q1 greater than 5, N2 P2 greater than 5, and N2 Q2 greater than 5. We'll show you how to verify that. Now, do we need to verify this? If he asks you to verify the conditions, you do. But if he doesn't ask you, just perform the hypothesis test. So to perform a two-sample z-test, it's called two-sample proportion test, guys. You verify that those conditions are true, which I'm going to show you in a second. You state the null and the alternative hypothesis. You calculate the standardized test statistic z. You calculate the p-value. You make a decision to reject or fail to reject the null hypothesis, and you interpret the decision in the context of the original claim. And the name of the test will be using here. It's called two-prop z-test. In chapter 7, guys, you used one prop z-test. Now you're going to use two because you have two samples. That's the difference between the two. And let's do a problem together and show you how to proceed with this one. In a study of 150 randomly selected occupants in passenger cars. So actually there are two subjects here, passenger cars and then trucks, pickup trucks. So look, guys, I'm going to do passenger cars here and pickup trucks there. So I'm going to label passenger cars as 1 and pickup trucks as 2, guys. So that's going to be the P1 and that's going to be my P2. So in a study of 150 randomly selected occupant passenger cars, so your N1, guys, is 150. There must be another sample size, you label it N2. In chapter 7, we just use N because we have only one sample. Now we have two samples, 200 randomly selected occupants. 86% of occupants in passenger cars and 74% of occupants in pickup trucks wear seat belts. So here we have an 86% and here we have 74%. So he says, out of the 150, 86% of them who drove passenger cars wear seat belts, and 74% of those 200 who drove pickup trucks wore seat belts. At alpha equals 10%, 0.10. can you reject the claim that the proportion of occupants who wear seat belts is the same for passenger cars and pickup trucks? So guys, can you tell me which one is it gonna be the claim? He says, can you reject? Look, once he asks you if you can reject a claim, that means the claim must be in the null hypothesis. So which one is it going to be? He says, can you reject the claim that the proportion of occupants who wear seatbelts is the same for cars and pickup trucks? So would it be first, second, or third?
Third.
Does everyone agree, guys? It is a third. Yes. He's asking us, is P1 equal to P2? So that is the third one. Yeah. And the claim is right here. So this time, the claim happened to be in the null hypothesis. Okay. Now, what is the 86% and what is the 74%? The 86%, guys, it's a proportion from the sample. It's called P1 hat. And this is called the P2 hat. Okay. How do I check the condition? Let's say he asks you a question to check if the conditions of the test are met. These conditions, 4 conditions. Let me show you how to check. Actually, here it should have been like this. So let me show you how to check, guys. Conditions of the test. I'm going to do it here on the side. If he asks you just to perform the test, you just perform the test without the checking the condition. N1 is 150, guys. Multiplied by P1 hat, which is 0.86. Will you get a number greater than 5? Yes. If you multiply, you're going to get a number greater than 5. Can someone tell me what's a Q1 hat here? If P1 hat is 86%, what would be Q1? Q1 is a probability 14. Of failure. 14%, exactly. So you do 150 times 0.14. And if you use your calculator, guys, let's see what's 150 times 0.14. It's going to be bigger than 5 for sure. 21. Bigger than 5. Checks. Let's go to N2 now. 200 times 0.74, guys. That's 148. Greater than 5. Checks. Okay. What is the Q2 here? If this is 74% deducted from 100%, yes, 26%. So 0.26 times 200, guys. This is 52, bigger than 5. The conditions of the test are met, so then we can perform the test. Okay, so this is how to verify the condition of the test. Okay. Let's go to the calculator and show you how to perform the test. Stat, tests. You should see it, guys. It's number 6. So section 8.4, it's number 6. 2 proportion z-test. In chapter 8, you only use 2 for section 8.4. All right. It's asking me for x1, n1, x2, n2. I don't have x1 and x2. I have n1, which is 150, and I have n2, which is 200. Do you guys know what x1 is? How do you find x, the number of successes? If you remember, and
well, P is equal to x over n, so you can just rearrange.
Exactly. So look, this is the formula for x, guys. P is x over n, so x will be P times n. So x1, guys, will be P1 times n1, and x2, I'm going to write it right here, will be P2 times n2. So here, if I want to find x1, it will be 150 times 0.86. And if I want to find x2 here, guys, it will be, sometimes they give you x1 and x2 and n1 and n2, you don't do nothing. But in this particular exercise, I didn't. So it will be 0.74 times 200. And you guys, you don't have even to do them by hand here. You can do them on the calculator. Watch. 0.86 times 150. I got 129. And 1 is 150. X2, 0.74 times 200. I got 148. And then N2 is 200. And now, guys, I need to select the sign from the alternative, which is not equal. And if you want to see a draw, for example, let me show you a draw. And that should be it. Okay. Z is 2.73. And the p-value is so small. Look, you don't even see the p-value. So I got 2.73. And the p-value is so small. Remember, p-value low, HO must go. So you're going to reject the null hypothesis. 0062. And we use 2-prop z-test. Okay, so p-value is less than alpha. Reject HO. And let's write the conclusion now. There is enough evidence at the 0.10 level of significance to, what's the magic word? Remember, the claim is an HO. To reject, yeah, the claim see, reject, you have to use the word reject. He has in the problem, that proportion. I'm just copying and pasting, guys, of occupants who wear seat belts is the same who wear seat belts is the same for passenger cars and pickup trucks. We are saying that we're rejecting the claim that it is the same. And in reality, guys, if you drive in a smaller cars, you'll be more worried about your safety, so you tend to put the seat belt. But if you're driving a pickup truck that is the size of 5 cars, some people wouldn't bother wearing the seat belt because they think they're safe. And indeed they are. It's a big car, you know, so it might have a little bit more protection, you know, than a smaller car. And that's why, guys, we ended up rejecting the claim that the percentage of people who wear seat belt is the same for small cars and pickup trucks. So it does make sense that we end up rejecting this claim. Any questions? We're going to do another exercise with this one. A medical research team conducted a study to test the effect of a cholesterol-reducing medication. At the end of the study, the researcher found that of the 4,700 randomly selected subjects who took the medication, 301 died of heart disease. So, medication, we had N1 4,700, and this is X1, guys, which already given. He didn't give you a percent this time. 301 died. So a success here if a person dies, you know, just because of taking the medication. Of the 4,300 randomly selected subjects who took the placebo. Placebo, guys, is a sugar pill, so it has no medication. This is the second group. That's how they do experiments. You have to have 2 groups. one who takes the medication, who takes the treatment, and another one is a control group, doesn't take nothing. Or you give them the impression that you're giving them a medication, but you're giving them nothing. And this is the placebo group. And how many were involved in the study? 4,300. And let's see how many out of the 4,300, 357 died of heart disease. So success will be how many would die of heart disease. At alpha equals 0.01. Can you conclude that the death rate due to heart disease is lower for those who took the medication than for those who did not take the medication? Lower. So which one is it going to be, guys? First, second, or third?
First.
You guys agree lower means less than. So that's, yeah, first, exactly. See, it's not difficult, guys. Lower means less than, so it must be this one. P1 is less than P2. P1 is greater than or equal to P2. And claim right here. P1 represents the ones who took the medication, and P2 represents the one who took nothing. And it's a two-prop z-test, guys. You're going to see how easy it is. If you can list this one properly and you list the given information properly, I think there is no reason why you should not ace this question. So it's just two-prop z-test and watch.
Is there ever a time where there's a two-prop t-test?
No.
Okay.
It's only a z-test.
Okay.
So that should assure you that there's only one test you look for, no other. Not unlike the mean. The mean there are z and t, but this one, that's why I'm saying it should be so easy. It's just one test, two-prop z-test always. So take a note of that. Number 6, x1, guys, 301. You see here, I didn't need to multiply m by p because he gave me x, so I'm all good here. 301. N1, 4,700. And I think you notice, guys, when you do medical experiments, you have to have a large sample size. And you notice my sample size is in the thousands here. And I didn't make up this exercise. It was adapted from New England Journal of Medicine. So X2, 357. N2 is 4,300. Just be careful as you enter the number, and we need to check that it is less than. Don't forget to change this one. Okay, like a draw. If I do a draw, if there is a p-value, it should be on the left because it's a less than. Oh, it looks like very small p-value. Okay, so Z is negative 3.46. Let me write the p-value, guys, that we notice here and interpret that for you. Don't write it like this as an answer. Actually, my MATLAB will not accept this. Okay, this means that you have to move the decimal place 4 digits to the left. The decimal place is right here. So if you move it 4 digits to the left, it's going to be 0.0003, which is for sure less than alpha, and you're going to reject HO. Once you see a minus E minus something, you know that your p-value is very small, guys. So you reject HO, and then your conclusion will be there is enough evidence at the 0.01 level of significance to, what's the magic word? The claim is in HA. Support. I hope that you guys get in the message by now. To support the claim that death rate due to heart disease is lower for those who took the medication. Than those who took placebo. So that means, guys, it's good to take the medication because we have evidence to show that it does reduce the heart rate. There's a lower chance of dying of heart disease, if you take the medication than if you take nothing. And that's how the doctors and how people sell, pharmaceutical companies sell their medication when they perform a test like this and they show it works. So in summary, for section 8.4, perform a two-sample proportion z-test for the difference between two population proportion P1 and P2. There's only one test, guys. It's called two-prop z-test. That's the test. Any questions? Okay, I'm going to do one more review exercise of this. It's toward the end. And I think it's number 4 right here. Section 8.4. Let's do a review exercise. Okay. In a survey of 500 doctors that practice specialized medicine, 20% felt that the government should control healthcare. In a sample of 800 doctors that were general practitioners, 30% felt that the government should control healthcare. Testa claim that there is a difference in the proportion. So you guys agree with me that the word difference means not equal to, and that's why I put P1 not equal to P2. So we have a P1 and we have a P2. You should have an X1 and N1, guys. He gave me N1, which is 500, and he gave me N2 here, which is 800. All I need, guys, to perform the test is the X1 and the X2. Look, guys, if he gives you a 20% to begin with, that's not an X. An X value has to be a whole number. So as you said earlier, if he give you the percents, you multiply it by N in order to get X1. So X1 will be 0.20 times 500. And guys, X2, you just apply the same thing, will be, what was the percent for P2, which is 0.30 times 800. You can do the answer now, or you can do it, just when you use the calculator, it doesn't matter. As long as you get a whole number. If you do multiply the two numbers and you get a whole number, you must round it to a whole number because X is number of successes, number of people. It can't be a fraction or it can be a decimal. So let's perform the test now, guys. Stat, tests, two-prop z-test, and watch. It's very straightforward. X1, 0.20 times 500. I can let the calculator do the math for me, no problem. And 500. Again, guys, you couldn't put 0.20 here. I know mistakenly some students will just put 0.20 because they see it right here. This is the proportion. You need a whole number there. So you take the proportion multiplied by N always. Let me just do that before I forget. X2, 0.30 times 800, it's going to be 240. And then N2, which is 800. And guys, you agree with me that it should be P1 not equal to P2. That's the claim. And let's do calculate this time. Okay, Z is negative 3.99. And look at the p-value, guys. If I write the p-value, what is it going to be? So let me write it down, 6.57 e minus 5. You can put almost 0, guys. So it's going to be, if you move the decimal points 5 digits, it's going to be this. There is a p-value, which is less than alpha, of course. So you reject HO. And you conclude there is Reject, there is. Fail to reject, there is not. There is enough evidence at the 0.010 level of significance to, what's the word, guys? The claim is in HA.
Support.
To support the claim. Definitely we're supporting the claim. To support the claim that there is a difference in the proportions. Yes, so indeed there is a difference in the proportions. A proportion means a percent, a ratio, a probability. So we concluded that there is a difference in the proportion. So that concludes section 8.4